Okay, on example 2, we're going to solve a cube root equation. So we're going to solve 4 times the quantity 2x plus 6 raised to the 1/3 power minus 9 equals 3. Okay, to remove a 1/3 power or a cube root, you must first isolate it and then raise each side of the equation to the third power. Okay, so I'm going to go through these steps and then I'm going to take a moment to kind of talk about these fractional exponents. So we want to add 9 to both sides. We want to isolate everything that is closest to our variable. So get rid of that 9. We end up with 12 over here. Okay, we want to divide both sides by 4 so that we just get the quantity by itself, not 4 iterations of that quantity. Okay, so the right side goes down to 3 divided by 4. We're going to cube each side. So we're going to multiply it by itself 3 times. We're going to do 3 times 3 times 3 on the right. 3 times 3 is 9. Times 3 is 27. Okay, now we can subtract 6 on both sides to get 21. And our solution will be 21 over 2. Now, the thing that I want to say and kind of pause on is this step. Why are we cubing each side? Why does cubing this get rid of that 1/3 power? So hopefully if we go through some examples here, we can see how those exponents kind of work out. So we are going to let's make some generic kind of question of hold on a second, gotta plug in my computer. Die in the middle of this video. All right, make a bunch of noise, drop a bunch of stuff, have some fun. All right, let's make this happen. Okay, so anyways, when we're looking at exponents, I tend to try to draw out the simplest exponents I can. To kind of show myself and remind myself how all of these exponents relate to each other. So if we have an exponent that's a fraction, so let's say 2 to the, or let's do a different number. Let's do 4 to the 1/2. Okay, how do I know that this is equivalent to the square root of 4? How do I know that those are actually the same thing? Why are we comfortable saying that if I cube this, I will get rid of it? Well, let's do that. So if we have the square root of 4 and we say that is equal to 4 to the 1/2 power, we're just going to say that that's true for now. What happens if we square both sides? Well, if I square this side, I square this side. Over here, the square root of 4 squared, well, by definition, that's kind of undoing that operation. We just get 4. And over here, what do we get? Well, we get 4 to the 1/2 times 4 to the 1/2. Okay, well, what do I do with that information? Let's try something else. If I have 4, what if I had 4 squared times 4 cubed? What would that be? Well, that would simply be 4 times 4, 4 squared, times 4, 4, 4, 4 cubed, right? It would be that, 4 squared times 4 cubed. Now, there's no distribution because there's no sums inside of these factors. These factors are themselves products of smaller factors. It doesn't matter if we write parentheses or not. We can say that 4 squared times 4 cubed is essentially just 5 4s in a row. So what did we do with the exponents? Well, we ended up with 4 to the 5th. Okay, so our general property here is that when we are multiplying numbers, when we're multiplying the same base, so the base here being 4, we're multiplying the same base and they each have an exponent, we can just add those exponents together. So what happens when we add 1/2 and 1/2? Well, we get 4 to the 1st power. Right? 1/2 plus 1/2 is just 1. Okay, so we do get 4. So it looks like that worked out. Now let's look over here. So if we have 2x plus 6 to the 1/3, which we are saying is kind of analogous to the cube root of 2x plus 6. We ought to be able to take both of these things and cube them and get the same result. Okay, so like I said before, on the right side, the cubing of a cube root, well, that's kind of inverse operations. They cancel each other out, and we get 2x plus 6. On this one, we get 2x plus 6 to the 1/3 multiplied by 2x plus 6 to the 1/3 multiplied once again by 2x plus 6 to the 1/3. And based off that previous example where multiplying similar bases, we add up the exponents, we're just going to get 2x plus 6 to the 3/3, or 1. Or, if you'd rather, just write it with no exponent at all. Okay, so this is why those fractional exponents work out. Okay, and as long as we can keep that straight, then we will have very little problem moving through these kind of examples. Okay, we'll move on to example 3 in the next video.